All right, so three types of volcanoes. Now, the different types of volcanoes really depend on what type of lava that they're made out of. Based on the last slide we just saw, there's three different types of lavas, but we're just going to talk mainly about the shield cone, the cinder cone, and the composite cone volcanoes today. The shield cone, these are really, really big volcanoes, but they're gently sloping, and these are made out of that very fluid lava, so they create quiet eruptions. You can see the shape of this kind of looks like a Roman shield turned on its side, and that's how they got their name. And this picture is in Hawaii, which most of the volcanoes in Hawaii are shield cone volcanoes. Shield cones are found near hotspots, ocean hotspots that is, because of that, all that basaltic rock from the seafloor is melted up into the shape of this volcano, and boundaries with lots of oceanic crust. Lava fountains and lava rivers are common. Be interesting taking a canoe ride down that lava river, huh? Okay, the next type of volcano, the cinder cone. These are much smaller than shield cone volcanoes, but they're very explosive, quite loud, actually. These are erupting basaltic and andesitic tephra. So it's not really as much liquid as just really hot rock that has some liquid in it, but it's mostly like actually really glowing hot rocks. Ash, which is very fine powder, lapilli, which is a little bit bigger than that, like pebble-sized, blocks and bombs, which are larger rocks. And so these things are dangerous on the local level, close by, but if you're far enough away from them, they pose no real threat. And there's a tephra eruption. This is in Iceland. The Eldfell volcano that erupted in 1973, which we're going to talk about when we do famous eruptions. So these cinder cones are often found on the sides of shield cone volcanoes and near hotspots too. Okay, moving on. Picture of a shield cone volcano out west. You can see it's very obvious. It sticks right up there. And the thing that you want to notice about identifying shield volcanoes is they have very steep sides because they don't run out. The lava is not liquid. It's particles. It's rock. So it just kind of tumbles down the sides and forms these steep cones of cinders. Hence the name cinder cone. All right, the last type of volcano, the composite cone. These guys are massive. Now they might not be as geographically large as the shield cones, but they are just imposing. They're broad-based, they have steep cones, and they produce the most deadly eruptions. You can think of it as alternating layers of basaltic and rhyolitic eruptions, the andesitic type lava. And so they have their times when they can build out a large base size, and then they have other eruptions which are very, very explosive. These are found where you have different rock types that are mixing. So the ocean-continental convergent boundaries is a very common place to find composite cone volcanoes, where, for instance, the west coast, off the west coast of North America, where the Juan de Fuca plate is subducting underneath the North American plate in the state of Washington. And this creates volcanoes like Mount Rainier and Mount St. Helens. Now these volcanoes, these composite cones, are often called stratovolcanoes because they're stratified. They have lots of different layers. You can see it here, alternating layers of lava and pyroclastic material. And it forms these steep cones and broad bases. And that's the telltale sign of these composite cone volcanoes. And they are big. So this shows Mount St. Helens before 1980. Very peaceful scene. This shows it May 18th, probably May 19th, 1980, after the eruption. And then just a few years ago, Mount St. Helens now. And you can see a new cone is actually forming in the exploded crater. And that new cone someday will take up the place of the volcano, perhaps filling this whole area in with a new volcano. And this picture is taken from the, I believe it's the Johnson Observatory which is located not too, I mean, we would not want to be there during another eruption, but it's a really nice place to visit when Mount St. Helens is calm. Okay, the hot spots. We talked about Hawaii as being a hot spot, and this picture shows Hawaii. This is the Big Island. That's the name of it, the Big Island. And there's the current erupting volcano, Kilauea. And all these islands, Maui, Molokai, Oahu, Kauai, and then all the way out to Midway, all these islands, these chains, were at one point over this hot spot. But the Pacific plate's moving, just like all the other plates are moving around. And you can see the direction of the motion of the Pacific plate right here. So as the plate slides, a new volcano forms over that same hot spot. So someday the Big Island will move this way, and a new island will form right here. In fact, there is one actually forming just off the coast of the Big Island, and someday we'll reach the surface. So hotspots, we know, are found near plate boundaries and in the middle of tectonic plates. As I said before, Yellowstone is also a hotspot. One thing you should know is that the brand new rock material is over the hotspot, and the oldest rock would be farthest away. The oldest islands would be farthest away. And when I traveled to some of these islands on a vacation in the far distant past, one of the things I noticed about Kauai, which is one of the islands I went to, was it had very, very steep, eroded cliffs on the north side, the Napoli Cliffs. And you can definitely tell that that thing's been eroded for a longer period of time than, for instance, the island of Maui, or even the Big Island of Hawaii itself. Some hazards from volcanoes. So here's an erupting stratovolcano or composite cone volcano, and you can see there's all kinds of dangerous stuff that can happen. So the magma comes up, it erupts out, and we have bombs flying through the air, large rocks, red hot. Perhaps there's a side eruption, a lava dome off the side, a dome collapse that you could fall in, a pyroclastic flow of glowing clouds, nuée ardente. This is deadly. These gases are much, much, much higher than the melting point. They would burn your lungs. We have lava flows. We have debris flows, or lahars. These things are deadly. Lots of these in Japan. They can mix with the glacial ice on the top of the mountain and form a mud slurry that just runs down the mountain very fast. On the other side, debris avalanches. It gets too steep, it collapses. You could perhaps walk over a fumarole and fall in and get cooked. And some more pyroclastic flows. The ash itself can blow around the planet, and when it does so, it could block sunlight, creating a cooling effect. Some of these eruptions that we're going to learn about, these famous eruptions, have cooled the entire planet by a few degrees for a long period of time. This has a bad effect on growing things. So volcanoes can be very dangerous. Now, one of the good things about volcanoes is to live near them, like in some of these Pacific islands. The lava flows and the rock is very fertile, lots of nutrients in the rock. So it's kind of like, you know, you got all these benefits, but then you have all these dangers to worry about too. It's a tough game to mix, to balance out. And that is it, the end of Unit 3. Thanks for watching.